Welcome to Lesson 5 of the Non-Musician's Intro to Digital Music Composition. For this lesson, we're going to dive a little bit more into synthesizer programming. So we'll start with a new blank project and keep working with resynth a bit, but really get into it instead of just tweaking one setting and then abandoning the window. So add a fresh instance of resynth, and we'll just go through each of these sliders and what each one means. Kicking off, volume is pretty much exactly what you expect. As a general rule, you want to manipulate volume as close to the source as possible. You should note that this track volume fader is different from this one. So ideally, you want to be manipulating this volume slider rather than this one. It's not a huge deal. You basically aren't going to notice any difference in quality between using the two, but that's just a good rule of thumb to keep in mind. And certainly using either of these is better than using the mastered one for obvious reasons. Moving along, tuning changes the pitch of every note played by the synthesizer by the specified amount. It's measured in cents, and all you really need to know is that 100 cents is one step on a piano keyboard. So if you tune 100 and you were to play an A with this synthesizer, the note you would hear would actually be A sharp up here. And likewise, if you set your tuning to -100, you would instead hear A flat or G sharp. This note right here. Tuning is, well, it has a couple of uses. If you're just working with one instance of resynth, then a slight detune in either direction, say something like 20 to 50 cents, can add a bit of character to the sound and make it stand out a bit more without being overly jarring. Just an aside, if you double-click on a slider, it resets to its to the value where this vertical line is, which is not always the same as the default value. If I double-click on this volume, it resets to 0, even though it initializes at -6. Just something to keep in mind. Attack is one of the standard 4 parameters of a synthesizer. You have these 4 here: attack, decay, sustain, release. You will probably see the acronym ADSR a few times when you start looking into other synthesizers, and that's what it stands for. Attack is how long it takes the sound to get up to its initial volume. It applies to each individual note played, so right now, with a short attack, the note just starts. If you increase the attack, we'll increase it to maximum, it'll take 5,000 milliseconds, or 5 seconds, for this note to reach full volume. Which basically results in a long fade-in. Now, because this applies to every note individually, if you have a long attack and a short, fast sequence of notes, like this, you will basically not hear anything. So it's important to know what you plan to use your synth for when you're setting these values. We won't get into it now, but you can tweak any of these settings, or any setting for any synthesizer, in the middle of a song, just on the fly. So you could change that, but generally if you do that too dramatically, it's pretty jarring, and people typically expect an instrument to sound fairly similar during most of the song. Moving right along. Decay. Okay. A synthesizer, when it plays a note, starts fading up from nothing based on its attack, and then once it reaches the attack, it then begins to fade down according to its decay to this sustain volume level. Because sustain is set at 0, there's no change in volume, and the decay value is not used. If I were to lower this sustain value, then the note would, over the course of 1,000 milliseconds or 1 second, fade down to this volume level and then stay there. Once it lowers, then it remains constant. Likewise, if I set the sustain level to positive, it'll fade up. And then hold there. This is most useful for creating like pad synths, which play in the background and change over time while holding a single note to add some character, warmth, texture, something a little distinctive to the background of the song, a different texture. And lastly, release. Release is how long the note keeps playing after it stops playing. In other words, when you let go of the note, how long does the sound take to fade out? With long release, it stays for quite a while. Much like having a long attack, a long release does not play well with fast sequences, because if you have a fast series of notes like this, and a long release, then they will get all piled up on each other. And you don't want that. Just a note, if you hear that choppy, distorted sound, that's called clipping, and it means your sound is too loud. Lower the volume, and it goes away. That's because digital audio is just incapable of getting above a certain volume level, represented as 0, which is why everything is measured in the negatives down here. And if it does get above that volume level, it just gets cut off, and you lose some audio data, which is why it gets crackly and staticky. Simple fix, lower the volume. Alright, so those are the 4 basic parameters. Now, Resynth has some simple manipulations here to change the wave shape. It starts out as a sine wave, which is the pure tone, as we've discussed. And then you can add in these other waveforms. Because this is a mix, it can only have a total of up to 1. So if I drag square up to 1, it's a pure square. If I leave square at 0.5, it'll mix half square, half sine. You can sort of hear both of those. If I drag sawtooth up to 0.5, it's now a square and sawtooth combo. If the total goes over 1, some of the waveform gets lost or averaged together, and it can be kind of unpredictable. So it doesn't like change with each note, but the way it mixes it together is a little harder to predict in advance. Fine if you're messing around, but if you're trying to consciously design a sound, you'll probably want to stick with your totals coming up to 1. Briefly, this pulse width slider only applies to the square wave, and it changes the character of the wave pretty dramatically. With a wide pulse width, you get this, well, wide sound. If you lower the pulse width all the way down, you get a much narrower sound that also sounds kind of retro. And somewhere in the middle gives you kind of a mix of both. Now, these synthesizers are really good if you want to make something that sounds like chiptune, old video game soundtracks. They tended to be very simple synths. Like, I think the NES had a square wave, a saw wave, and 2 triangle waves, and then like a sound effects channel. But fancy synthesizers, modern music, and all that good stuff are usually a little more complicated. They don't just generate one tone, they generate several. One synthesizer that I use pretty regularly is Citrus by Imageline, and that has, I think, 7 different waveform oscillators, and then you can have them all mess with each other, and it gets incredibly complicated. So, instead of dealing with that, we're going to add 2 more instances of Resynth and make a simple layered lead. To start, let's reset everything in the first synth to the default, and bring up sawtooth to 1 on all 3. Without changing anything else, that's just going to make it louder. So on the second one, we'll change the tuning value to 20, and on the third one, we'll change the tuning value to -20. Now, we have a sound with some character. Quick bit about music and just how it works. If you have two notes with similar frequencies, you get what are called beats, where the frequency of the note oscillates between those two frequencies. So by having one above and below, you end up with this pulsing sound. That's really cool. If you have the pure frequency, there's no pulsing. If you were to, say, increase the distance between them by 300, which is 3 steps up on the keyboard, or a minor third, and 700, which is 7 steps up on the keyboard, and a perfect fifth, you would get the 3 notes of a minor chord when you play one note. Because the interval in the frequencies is larger, the pulsing between them takes longer. So you end up with this more, I don't know, you tell me what the mood is, you know. I think it's kind of a mellow organ-like sound, but when it comes to programming synthesizers, I've learned everybody hears different things. Okay. Generally, I don't use one-button chord synths like this. This is set up so whatever you press, you get a minor chord, because they're just not as flexible. If you wanted to stick in a major chord and you were using this synth, it would be awkward. So instead, I would set up something like the -20, +20, and then just write in the chords myself. Thusly. That has a pretty interesting sound playing chords, actually. I was worried it would be too messy. But it's pretty good. Another thing that's important about using these small tuning changes is you don't want your instruments to take up too much space in the mix. You don't want them to have too wide of a frequency. So I'll slap an EQ plugin on here, and we can take a look at this. That's kind of messy. But if it's playing just one note, okay. By adding these tuning changes here, we've picked up some noise in the low frequencies. If you look at just that bass tone, oops. Alright, apparently the saw wave does have some noise in the low frequencies anyway, so this is a good example. As has been discussed before, you basically want to get rid of that to make room for everything else. And that's not going to change the character of the synth too much. We can add in those overtones again. And generally, because leads and melodies are higher pitched, I would drag this up somewhere around here. Alright. So that's a bit of a lead synth. Like that. Okay, enough messing around. One other thing that you can do is change the waveform of the overtones. So rather than having the overtones be saw, I might make them triangles. Just as an aside, triangle waves are quieter than other waveforms. I'm not actually sure why that is, it's just a little quirk of them. That's really sounding like an electric organ. That's pretty cool. When you mess around with synthesizers, you'll often come up with these cool combos that you really like. What you want to do then is go into this box here and click these 3 dots. Wait, no, sorry. Right, okay. Go up to FX and save FX chain. I usually just hit Control S, but I wanted to show you where the button was. So, and you can save this as synthesized electric organ. By default, it goes into your app data roaming Reaper FX chains folder. I think that's a fine place for it. If you'd like to move these things around, you might want to put it somewhere else. Anyway, there that goes. So then later on, you can add FX chain, and then select this, and boom. Now in this case I added it twice. Doesn't really do much. Have it duplicated. Anyway, there you go. That's a little bit more about programming synthesizers. Before we end, I'll just touch on these last two sliders. The extra sine mix adds a sine wave on top of the existing wave. So disabling everything else, dragging this up to around 0.5. You get this extra sine wave, which, even though it's not tuned differently, because of the differences in how a sawtooth wave and a sine wave produce sound, you still get that oscillation. You can also manipulate the tuning of this. Say if I wanted to bring it up 300. That's got a serious retro sound to it. Just another feature you can play with. Remember that the extra sine mix is extra because it's added on top of the others, and it doesn't have to add up to 1. It can be anything at all. I hope that was helpful, and have some fun playing with synths. Thank you for watching, and stay tuned.